Hi all. So speech to text is a fascinating space, and as a developer I genuinely get excited whenever I get the opportunity to explore new technology like this. It's always a chance to sharpen my skills and add another feather to the cap. So when speech to text or STT as we call, when the requirement comes up to us as a developer, it's not just a task. It's an invitation to learn how to approach the problem end to end. In this hands on Python course, we will dive into framing the STT challenge, the requirement as a developer that you should know before starting development, choosing the right model, online versus offline, handling audio streams and files, and writing clean and reproducible code. So, as a developer, when the requirement comes to you, you should be aware of the challenges that or the requirement details that you are going to need to start the project. Okay, in the company networks you may also face issues for zscaler or vpn related issues that also we will take care here. Okay, this course is more about using the existing tools, so we are not going to do any model training as such, because unless you are in that space specifically, your requirement will be only do a speech to text conversion, like in whatsapp audio button, or on a chat box or chat window you include a speech to text icon like that. So not specifically training on models we are doing, we are going to use existing tools available in the market. Okay, before we begin, a bit info about myself. I am Abhishek Upele, working as a senior developer in one of the MSCs. I am also a PhD researcher under Manipal Academy of Higher Education, specializing in responsible AI. So again, welcome to this hands-on course on building robust and scalable privacy-aware speech-to-text system using Python. If you have a specific issue or problem in this space, you do feel free to comment me. Okay. And GitHub link to code is available in the description for easy access of the code. Okay. So let's start. So let's go through the course outline. First, we will go through introduction to speech to text, defining problem or requirement. You will understand the key challenges in speech to text conversion. Then we will have hands-on Python code using offline model, that is Vosk, then GCP model, chirp, and other endpoint of GCP. Then we will go through client server setup, that end-to-end pipeline for speech to text conversion. Then we will explore further models of AWS, Whisper, Azure, and other offline models. Then we will compare the performances and see how to optimize our latency or the accuracy, whatever issues we face. Then deployment in Docker, Kubernetes. So in introduction to speech to text systems, we understand the problem, the requirement, types of speech to text models available, and challenges. Okay. So as a developer, when your lead or project manager asks you that we want to integrate speech to text conversion, suppose there is a chat box and you want to give an option for that user will speak and it will convert to text, then the text will further go to llm for question answer, or you can process that text whatever way you want. Okay, so this is a live audio stream, or maybe you want to convert some files to text, audio files to text. That is also one use case. Okay, so there could be files as input, audio stream, and in files and audio stream there are also other sections like what is the length of the size, or file size or length of the duration of the audio file. Okay, so if it is less than one, there are other APIs. If it is more than 1 minute, there are other APIs. If it is live stream for shorter duration, there is other method. Or if it is live stream, unending live stream, there is other endpoints to handle it. Okay, the latency and accuracy. So if it is a live stream, then how much time it takes to get the output, because user is not going to wait for longer duration. As well as the accuracy matters. Okay, you cannot have shorter time and low accuracy. So acceptable latency, which is the time it takes for your speech output to convert to text, and you get the output and you further process it. And accuracy also matters. What language you want to support, English, French, that also comes under requirement. Okay, so when a requirement comes up, you will have questions like what language we are supporting, it is live audio stream, what is the duration of that audio file or live audio. Okay, how what the challenges you should also know, that how much time it takes for that speech to text conversion, is the conversion accurate. Okay, the types of model to use. So there are offline models and online models. Online models are supported by cloud providers like GCP, Azure, AWS. There are also some offline models, um, but that then here lies the difference. Okay, the offline models may not have that much accuracy, because if they had that much accuracy, then why would GCP, Azure, or AWS spend resources or money in developing or hosting speech to text endpoint or API? Okay, so people pay for it because it is more accurate, and offline models are not that accurate, maybe not that accurate, or maybe useful for your use case if it is simpler uh, audio. Okay, so I have found out key for simpler audios like number conversion, like it is numeric says 1 2 3 4, or some for some use cases maybe offline model is acceptable, okay, due to cost constraints. But for better accuracy, GCP, Azure, or AWS model will be good. Okay, and model performance parameters you have to look into using both of them, like accuracy, latency. Okay, now, challenges you may face. Okay, so it may be intuitive to you, but maybe it took me one day that I figured out. In streaming audio from client to server, uh, most of the time, I mean always, your server will be running on backend on some VM virtual machine in Linux, and your client side is browser where you actually are going to input your audio. Okay, so these two systems are separate. Your server which is actually going to process your audio, you have to pass your audio from your client side, from your local machine, your laptop, capture it and transfer at the back end to the server where that conversion will happen. Okay, so this is one challenge. You have to capture at your client side your audio, specifically your live audio, you have to capture at client side, then send to server, and in and that whole exchange latency and accuracy you have to take care. One more issue that is very difficult to face. So in companies, you have Zscaler or VPN security policies, and often many APIs give me, especially GCP API gives SSL certification error. Okay, so how to tackle that? Then also you may issues related to frame rate, etc. Okay, so we will tackle those issues in detail. Okay, so requirement like model, type of model, type of input, client server architecture, latency, accuracy, that we already discussed. Now types of model to use. Okay, so there are online models like provided by GCP, Okay, Amazon Transcribe, Azure Speech Services, Assembly AI, DeepGram, and other services are there. Okay, we will explore some of the services which are most popular. Okay, we will start with GCP. In offline model, you have Whisper, which is open source, Vosk model, and NVIDIA models. We will see them, whichever popular models are there. We will try to cover maximum of them. Okay. Hi all. Uh, so today's topic is Vosk, which is an offline model. Offline means we can run it without internet. Okay, so the model file will lie in your local folder. Okay, so we will cover Vosk setup, cloning, virtual environment setup. Then we will go through the Vosk models. Then we will do hands on Python. So let's go ahead with code. So let me walk you through the Vox website. Just Google Vox, go to this link. Now on the left side you see a menu bar. So installation and models is what we will look into. So go to installation. So it will tell you steps for installing on Mac, Windows and Linux. Okay. So let us set up this on our local. Okay. I'm going to clone this repo here. Okay, done. Let us open this. Now we are going to set up virtual environment here. Okay. So you see virtual environment is created. Now we need to activate it. So go to VN folder, scripts. Use this bat file if you are on CMD terminal. So if you see here, the PowerShell CMD terminal. Okay, so I am on PowerShell, so I am going to use this file. Right click, copy path, paste it here. Okay, yeah. So our model is activated now. Now we need to install Vosk package. So pip install Vosk. Okay. So sometimes you will get an SSL error if you are on VPN or Zscaler. So to in pip install. So to fix that, you can use one more command. So if you get an SSL error on your company network, you can use this command. Pip install trusted host pypi.org, and at the end you put the name of the package Vosk. Okay, yeah. Okay, so now let us go to the model section. So these are the commands. So let us try to run this Vosk transcriber. So but okay, so you need to give the path of the file. Okay, of this clone repo. There is one file test.wave, and this is the path of this file inside Vosk API path and example test.wave. So in this command vosk.transcriber -e, give the path of the file. Okay, and then output file test.txt. Okay, then run it. Yeah, yeah. So it is expected to fail. Now two reasons. Now one is key. FMPG package is required for it, okay, which may or not be available for you, okay. Second is it loads the model in cache online, okay, so it's not showing right here loading because already it is available in the cache directory, okay. But in production setup you don't want to load models on the fly, okay. And setting up FMPG in Docker also is one more task, okay, with its own challenges. So we will try to do it without this Vosk transcriber. And in production, we need a Python file. So okay, we will go with that approach. So if you go to the URL, uh, so here you see the command. So we have cloned this repo. Then we will run this commands, okay, and then see the output. So let's follow these steps. Before running this, let us hear what this input file test.wave actually sounds like. So I'm gonna play this now. Okay, now let's execute the script. Okay, let us install Vosk here. Okay, I think it has to do with Python 3. Okay, now it's running. So you see it gives some output. So the actual audio contains 100190210018003. So let us see what it is generating. So it is 100, okay, 100, 10001. Okay, so this seems wrong. 00, okay, 01803. So partially it got some of the text correct, okay. So now let us go through the models available. So these are the models, okay. Size and word, error rate or speed, notes, okay. Brief info about the models, okay. So it has Indian, Chinese, Russian. So you can try all these models. Okay, let us go through the code once. Okay, of this file that we ran, test underscore simple.py, and this repo has multiple uh, files for Java, Node.js, Python. You can try those also. And examples also there are multiple files. Okay, let us go through this code. Okay, so this is the test.v file that is being read here. Okay, and audio file must be wave format mono PCM. Okay, model LAN ENUS, that is this model, Giga model. Okay, Vosk model ENUS. Now this you are here getting the frame rate, because if frame rate mismatch is there, it may not convert it to text properly. Okay, Okay, so now here we see that where is the model actually. So it is downloaded from internet, okay, or it is available in cache somewhere. But in the production, you don't want to connect to internet. Maybe client has access issues, so it is better for offline model. So this is one time download, but that also may be restricted. So here you see you can give the model path, okay. So let us try with that also, downloading the model, okay, and then trying. So let us go to website, let us download this model. So it is a heavier model, 2.3 GB, so it is gonna take some time, okay. So it took me 40 minutes, okay. So let me just skip it to the next part after download. Okay, so I have downloaded the file here, the model file. So let us change the path to this file, comment this, and Windows make sure to indicate double backslashes. Okay, so I update the path here. Let us run this. Okay, but it is giving some error. Okay, because we are not passing model name but model path. If you go inside this, you will see model path is one of the variable. Okay, so instead of model name, we will give model path here. Okay, great. Now let's run it again. It actually take a bit of time, which is on a higher side compared to online models also. Okay, now got it. You see 100 something, yeah, 922. Okay, so okay, we got some result. Okay, now let us try one more file. So we will try harvard.web. So this file only has numbers, that file actually has English text. Again again to download it, to just search for harvard.web file, go to kaggle and click on download. Okay, I'm going to place this file on the same path as test.wave. Okay, okay, so you see harvard.wave is here. Let me run the command again. After we get the result, we will see the actual audio. We will hear the actual audio of harvard.wave. Okay, okay, so we got this error. So let us try to convert this file to monopcm format. We are going to need fmpg for this, so let us download fmpg. Okay, go here, linux linux. Okay, so I think this is for windows 64. Okay, so we have FMPG downloaded. Right, so we see this error. Audio file must be WAV format mono PCM. Okay, so let us convert into mono PCM format. For that, we will need FMPG. Okay, so once you download the FMPG, you need to set the path of FMPG in the system environment variable. So, okay, to go to system environment variable, path variable. Now add your path like this till bin. Okay, FMPG slash bin. Okay, then okay, do okay, apply okay, whatever comes. Then maybe close that terminal and reopen another terminal, and to check that if it is installed or not, you need to run fm mpeg dash version. Okay, okay, so something like this will come, version and other details and no error. Okay, so it is installed now. So let us convert it. So I am on that harvard.wave file path. I am going to use this command to convert this to output.wave file, harvard.wave, using fmpg. Okay, so this is a simple command, so you can get it using copilot. Okay, so okay, so it already exists, so let me overwrite it. Okay, great. So let us try to run with this file now. So file is saved with output.wave name. Okay, so run this. Okay, so conversion has started. So you see some words: cold, dip, pickle with. Okay, okay. The stale smell of old beer lingers. It takes heat to bring out the odor of a cold dip, restores health, and just a salt pickle taste fine with the ham, tacos, all pasta, or my favorite a zestful food is the hot cross bun. Okay, so let us see what actually Harvard.wave audio looks like, or when we hear it. Okay, okay, let us open this. Let me run this. Okay,
The stale smell of old beer lingers. It takes heat to bring out the odor. A cold dip restores health and zest. A salt pickle tastes fine with ham. Tacos al pastor are my favorite. A zestful food is the hot cross bun.
so that's really good. Okay, exact conversion, I would say, very accurate. Okay, so good. Okay.